Hello and welcome back to another video series. We will going to look at the topic 2, which covers the hardware architecture of a microcontroller. When we talk about the hardware, we are talking about the physical components that are present inside the microcontroller chip. And in this discussion, we are going to look at the CPU core of a microcontroller and how does it operate and what are some of the main parts inside the CPU core. And we are going to look at the memory map, and we previously discussed what is a memory. A memory is mostly used to store information or data inside a microcontroller. And in this case, we are going to look at how those memory layout will be and how it is allocated and accessed inside the microcontroller. And also we are going to look at the peripherals. When we talk about the peripherals, what do we mean by the peripherals, such as the hardware for the input and the output module, which facilitate the transfer of information. And the peripherals is nothing but some form of modules which allow the microcontroller to operate with the outside world, such as accepting an input or giving out an output to such module, which are known as the peripherals. And finally, we will look at the buses. When we talk about the buses, we are talking about the path in which information is transferred, such as the address bus, the data bus, and the control bus. And we will define each of these buses and their function in a microcontroller. And this is a 3D model of some of the microcontroller that we have. And inside those models, we have what is called the architecture. And the summary of this architecture, like we have given as an outline, we can be able to see that all of these will be discussed, which is now based inside this particular microcontroller, where we have the CPU, which is known as the brain of the computer, and we have the section where we have the memory where data can be stored, and we also have the peripherals such as the GPIO, general purpose input and output port, where data can be transmitted to an external peripheral module or receiving data from the input peripheral, such as a push button, a sensor, or from another microcontroller. And now I will begin our discussion with the outline 2.1, which is the study of a CPU core. And the CPU core, which is also called the central processing unit, is the brain of a microcontroller. So we have what is called a microcontroller, and this microcontroller has what is called the CPU, and this CPU is now the brain of this microcontroller. And what this particular microcontroller does is that it will mostly fetch information. And we all know that if we have a microcontroller MCU, and inside this MCU we have the brain, which is called the CPU, and then we also have what is called the memory. And once when we program, we are now giving the instruction in terms of the program code. And from our discussion and our microcontroller labs, we can be able to see that this program code will be stored inside the memory in terms of a binary X file. And from there, what the CPU does is that it will now be able to fetch this information, and it will now decode this particular information stored in the memory, and then it will execute. And in that case, we can be able to say that this particular CPU will fetches information which is stored in the memory, and it will decode, and finally it will execute. Therefore, we can be able to see that this particular CPU execute the program instruction which is stored in the memory and control the overall operation of the device, such as the microcontroller. Since the microcontroller itself has a lot of components which make up the microcontroller itself, in order to control all these components, we need the CPU. That is why the CPU plays an important role in a microcontroller. Without a CPU, it would be very difficult to control all these small components and devices inside a microcontroller. Now we are going to look at the main parts of the CPU, which is the circuit that is found inside the CPU, and this circuit plays an important role in executing the information. The first main part inside a CPU core is called the arithmetic logic unit. It is also called the ALU, and the function of this arithmetic logic unit is to perform mathematical and logical operation. Mathematical and logical operation are two different operations that can be suggested. Now, when we look at a mathematical, so what is a mathematical operation? When we talk about the mathematical operation, we are talking about the operation that can be performed inside the CPU, especially the ALU unit inside the CPU, such that it can perform addition, and secondly, it can perform subtraction, and it can also perform division, and we can say multiplication. Those are some of the operations that can be performed inside the ALU of a CPU core. And we deal with the number that is in terms of a decimal, where we have 1 plus 1 can be equals to 2. And since the ALU is a digital device, it performs operations such as binary addition, and we can have binary subtraction, and so on. And since when we perform using a number system which is called a decimal number system, it is the same operation. However, those decimal values are converted into a binary, and then this particular ALU can be able to perform those addition, subtraction of the values which are in binary. You can also check our video in digital system where you can be able to convert from a decimal to binary, binary to octal, or binary to hexadecimal, and you can learn how the conversion occurs. But the main thing you should remember that in the ALU, you can be able to perform such mathematical operation based on the binary form, such as binary addition, binary division, and binary multiplication. And the other thing is that we have the logical operation. And when we talk about the logical operation, it is quite precise. And we know that performing the AND operation, we have OR operation, and we have NOT operation, and so on. For the AND operation, if we have true and we have true, the output will be true. And if we have, for example, false and true, we should have the false. And it follows the AND gate, where we have, if we have true and true, the output will be true. And this is the condition of the operation in which the arithmetic logic unit will perform based on the specific gate. When we look at the OR gate, when we have true or false, we can have the output which is true, except for when we have the false and the false, the output will be false. That is for the OR gate, and this operation follows this particular OR gate, and this is why the CPU can perform this type of operation. And finally, we have the NOT gate, where when we have the true, the output will be false. When we have the false, the output will be true. And now you can be able to understand the difference between what is a logical operation and the mathematical operation. And both are different operations that can be performed by the arithmetic logic. And now we have what is called the control unit, which is the second main part inside the CPU core. And the function of this particular control unit is to direct the operation of the CPU by interpreting instruction and generating a control signal. And we know that the instruction will be stored inside the memory. And we have the memory circuit which stores the instruction. And when we fetch this instruction from the memory through the CPU, and this CPU can now be able to process, and we have inside the CPU what is called the control unit. And what this control unit does is that it will now, upon interpreting the instruction, and if we say we have in terms of the Arduino IDE, we have the function digital write, and we say pin 3, which must be high. And this is now a particular instruction that is stored inside the memory. And when this microcontroller reads this information through the CPU, now the control unit will generate a signal such that it will now be able to select the pin corresponding to the port to be I. Therefore, it will now send a signal to a particular port, and this particular port having what is called the pin 3. And this control signal is responsible for generating this control signal, so that this pin 3 must have a positive 5 volts. That means upon this instruction, this particular control signal will now enable the port to pass positive 5 volts as an output, because we are writing a signal to the output pin. And without this control signal, this particular pin cannot be able to have a logic I or positive 5 volts, That is why it is important that this control signal will now control the port to allow pin 3 to have a positive 5 volts at the output, which can control other external peripherals such as an LED or a motor and so on. Thank you for watching our video. Kindly subscribe to our channel and share this video with your friends so they can also be able to learn.